Okay, so as I mentioned yesterday, the topics this week are going to help us connect everything we learned about right triangle trig with the unit circle as well. So today we're going to be talking about reference angles. And a reference angle is also used to find point and plane, which you were working on yesterday. So the definition of a reference angle is the acute angle formed by the x-axis and the terminal side. So if you remember from geometry, we have acute angles, right angles, and obtuse angles. So acute angles just means that it is less than 90 degrees, is the definition of an acute angle. So we're going to do this with a few examples. We're going to start off working with degrees, and then we'll also do this with radians as well. And I'm going to show you how to do this in each of the four quadrants, but we're really only going to focus on 3. So my first example is 135 degrees. So that would be found in the second quadrant, halfway between 90 degrees and 180. So this is my angle here. Now, if I wanted to find the reference angle is actually the angle formed by the x-axis and the terminal side of that angle. So this angle inside here would be my reference angle. Now, it's going to help us to remember our quadrantal angles. So remember, we start off with 0 degrees, 90 degrees, 180, 270, and then 360 degrees. So we're really going to be focusing on 180 and 360 because that reference angle is between the x-axis and the terminal side of the angle. So anytime you're looking for the reference angle, you want to take the larger value minus the smaller value. And what I mean by that is, if I know that this is 135 degrees, I'm looking for the difference between this x-axis and the terminal side. So to find my reference angle, I would take 180 degrees minus 135 degrees. So that gives me a reference angle of 45 degrees. For 210 degrees, so that's going to be about 30 degrees past 180. And again, I'm looking for that angle between the terminal side and the x-axis. Well, now, if I want to do the larger minus the smaller, if this is at 210 degrees, my x-axis here was at 180 degrees. To find my reference angle, I would do 210 minus 180 degrees. So that gives me a difference of 30 degrees. That would be the measurement right inside here. And then my final example in degrees is 295. So 295 would be found in the fourth quadrant. So all the way around here is 295 degrees. But again, we are looking for just the angle measurement between that x-axis and the terminal side of the angle. Well, I know here that the closest measurement of this x-axis is going to be 360 degrees. Always do the larger number minus the smaller. So to find my reference angle in this case, I'm going to take 360 minus 295. And that means my reference angle is 65 degrees. So this measurement inside here would be 65 degrees. Or if I added 65 to 295, I get to 360. So I'm going to pause the video for just a moment. If you need to rewind, kind of go back over some of these problems, and then we're going to do the same thing but with radians. Okay, so we're going to find reference angles with radians this time around. So 2 pi over 3. Keep in mind that 2/3 is 0.666 repeating. So that's a little bit more than half. So that would be right about here. And again, I'm going to jot down kind of my quadrantal angles so I can reference those. So I have 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So if I want to find the reference angle for 2 pi over 3, that is the distance in between the x-axis and the terminal side. So this time we're going to take pi minus 2 pi over 3. Remember, for when you were finding coterminal angles, we do need a common denominator. So since my denominator is currently 3, I'm going to multiply by 3 over 3. So I end up with 3 pi over 3 minus 2 pi over 3, which gives me pi over 3 is my reference angle. So this angle inside here would be pi over 3. For 7 pi over 6, so 7 over 6, hopefully you can see is a little bit more than 1. So that would be right inside here. And then the x-axis, so the closest degree measurement, or radian measurement, sorry, is pi. Again, I always do the larger minus the smaller, because your reference angles should always be positive. So to find my reference angle, I would take 7 pi over 6 minus pi. I need a common denominator, so I multiply by 6 over 6, which gives me pi over 6. And then finally, 9 pi over 4. So this is just a little bit more than 2 pi. Sorry, I'm going to actually change this example. Why don't we go ahead and change this to 7 pi over 4. So 7 pi over 4 is going to be just a little bit less than 2 pi. So it's going to fall in our fourth quadrant down here. So this is 7 pi over 4. And now the x-axis going to be closest is 360, or 2 pi. So to find my reference angle, I would take 2 pi minus 7 pi over 4, because 2 pi is larger. I need a common denominator. So this time around, I'm going to multiply by 4 over 4. So I end up with 8 pi over 4 minus 7 pi over 4, which is 1 pi over 4. Okay, so now for just a really quick recap. And I need a little bit more space here. So I'm going to try and fit this in right here. So in angle measurements, in the second quadrant, to find your reference angle, you would take 180 degrees minus that angle measurement. In degrees, we take pi minus the angle measurement. In the third quadrant, we would do our angle measurement minus 180, or our angle measurement minus pi. And then in the fourth quadrant, we take 360 degrees minus the angle measurement given, or 2 pi minus the angle measurement given. The reason I did not cover the first quadrant or any examples from there is because your reference angle is going to be equal to that angle measurement, because any angle measurement in the first quadrant is an acute angle or less than 90 degrees. That's all.